of what I'm going to have to say comes from two books. Brief History of Time by Stephen Hawking. Wonderful book. And then a follow-up book, 13 years later, The Universe in a Nutshell. And both very powerful books, and Stephen Hawking will tell you, one of the things that he was trying to do, his goal was to take the world of physics, which is in, and I cannot say enough positive about the understanding of physics and physics professors. I personally consider it incredibly complex, and anybody that devotes their life to physics, I see them as a genius, period. I'm trying to understand this in the terms of the man on the street, which I think I am. And that's what Stephen Hawking tried to do here, and he will tell you this. And that's maybe the primary reason it sold 10 million copies. Went into, I think it's 20th printing in less than 2 years. And it's a staggering tome. And if you start reading, 13 years later, he brings out things in here that he corrects himself from what he wrote in his first book, because knowledge is still expanding and is going to go on for a long time to come. And he talks about finding all of the ultimate knowledge that we can come across in the macrocosm. One of the things that Stephen Hawking said, and, well, incidentally, let me tackle Einstein here just for a second. Einstein, when he first came out with E equals mc squared, he thought the universe was static, and that it had always been and will always be. I don't know very many people in the world of physics today that would agree with that, especially considering the application of the first law of thermodynamics that I just mentioned. It stands to reason that if you cannot destroy anything, it could not have been created. So that has been crossed out. Now, after Einstein, well, wait a second. Let me tell you this little story. Einstein came to the United States in 1931 to attend a conference out in Pasadena, what's now in the Hale Observatory, but I think it was called the Mount Wilson Observatory back then in 1931. And there was a Belgian professor, and Einstein was attending the lecture. And this Belgian professor, Abbé Georges Lamartre, I don't know, some of the professors here may know this. But anyway, he gave a speech to all of these physicists out here, outlining the Big Bang. And during that speech, towards the end, Einstein stands up and starts clapping. That's it. That is the beginning. You know, look at this. And that was in 31. So the last, and incidentally, Einstein would have been considered a deist by any theologian in the first 2/3 of his life. But then, people that did not want to see value in Einstein and relativity, they began to try and demonize Albert Einstein. So what they did, they wanted to find God in his equation and they couldn't do it, so they tried to label him an atheist. And that was not true. But if you take, it did describe Einstein very well, but only from the classical evolutionary sense of the way the word got started, but not how it got to be demonized. A, as a prefix, means without. I mean, if you, in Biology 101, if you have an asexual protozoa, it's a protozoa that reproduces without sexual characteristics. Okay, so A means without. Theist means religion. Very early on, Einstein rejected his Hebrew religion. But he said also, a snail can shed its shell and still be a snail. I can shed my Hebrew theology and still be a Jew. And Einstein also, cute little anecdote of his, he said if relativity proves to be true, I will be known as a great German. If it proves to be false, I will be known as a wretched Jew. Those were his words. But anyway, and in the last third of his life, that would have been more applicable. But he used the word God basically like a deist. But the last third of his life, it came to mean less and less to him. And it would be hard, he would be hard-pressed to actually pin him down in the last third of his life. But anyway, Stephen Hawking made a big deal because he was the guy that, and he wasn't the first that came up with the idea of black holes in the universe. But he was the big promoter of saying, you know, it's just a matter of time, we're going to find them. And he got to see, and I think his doctoral thesis in physics, and I'd love for somebody to verify this for me someday because I've never come across it, but I think his doctoral thesis in physics was on black holes, but I don't know that. And a black hole is a collapsing star that has burned out all of its oxygen and it starts to cave in on itself, and the curvature of space-time around it creates such a gravitational field, and I want to discuss that in a minute, and it is so powerful as it's collapsing that as it collapses, it is so powerful that it will not even allow a beam of light or a wave of light to escape. It will bend that wave of light back into itself. Now, in his first book, Stephen Hawking got to see, I think in the late 70s, the first 3 black holes discovered in the universe. Now they're guesstimating that there's approximately 350 million black holes out there. Maybe we could get somebody here at the university to give an exact count of that. But anyway, now in his first book, A Brief History of Time, Stephen Hawking says that these black holes will be reduced down to the same thing that physicists call the Big Bang. It will be a singularity. Now, I wanted that in red. That is a big deal in the world of physics. Singularity, you can't separate anything. In fact, Stephen Hawking, in A Brief History of Time, says, well, I tell you what, when you get this black hole to reduce, keeps reducing down and caving in on itself, pulling everything in and in and in, it keeps getting smaller and smaller until you have a singularity. And I thought, that's it. That is it, because Stephen Hawking, when he talked about the Big Bang, he didn't go back and say that's where it began, because if you can't destroy anything, and all of these particles were in that singularity and it imploded on itself, where did it all come from? If it's infinite, if it is eternal. Okay? So, Hawking says, look at this, came from the cosmos. And look at our cosmos since the Big Bang, and let's just say this is where we are. Think about this, folks. I am absolutely overwhelmed at the brilliance of Stephen Hawking. When he was in high school, using a common telescope, and just looking, holding it in his hands and looking out into the universe. Oh, we don't have a static universe. There's red light coming from those farthest galaxies, and if there is red tint to those galaxies, that means they're further out because of the wavelength, and subsequently the universe is still expanding. We do not have a static universe. And they did this in high school with a handheld telescope. Do we have the makings of a modern day genius there? But anyway, now, so then, as you look at our vision since the Big Bang, then the universe is expanding, expanding, expanding. Well, let's just say we're right here at 14.7 billion years from the Big Bang. And they can measure this. They can look at the distance of these stars, calculate the speed of light, and go back to the focal point and where it began. We now know, there might be one or two people in this room old enough to remember when televisions had dials. And remember when you turned the dial, it would give that gray fuzz between channels? We now know that 3% or 3 to 4% of that disturbance between channels comes from shock waves from the Big Bang that are still reverberating through the universe. And anyway, so now if you come out here 14.7 billion years, and Stephen Hawking has estimated that we're about 200 million years from peaking the expansion of the universe. Now, if then it's going to start coming back together, and we're going to end up at the big crunch, when it's going to be reduced down to a singularity again. So, matter and energy are leapfrogging through the symbol for eternity. Particles cannot be destroyed. They have always been, and they will always be. And I was rather amazed, and by reading Brief History of Time, I thought, apparently erroneously so, that you would have all of these black holes, and the one that was the oldest and the biggest, the biggest bully out there, would keep gathering in these other black holes and everything that existed until you came down to the big crunch. And once you got down to the big crunch, it would keep coming in and pulling in and pulling in and pulling in until it could no longer pull in, and then it would implode on itself and it would all start over again. So matter and energy are leapfrogging through eternity. And the only way that you can understand the evolution of infinity is to look at the flow. And if you follow this logic,